Okay. Good morning. Good morning to all. Welcome to this presentation. We'll come back with this presentation. This is a simple presentation about a new technology, relative new technology, the WebAssembly, and with the scripted and C++. I'm Lorenzo Veneri. I'm C# developer, and I produced this presentation for another type, I did this presentation another way, in another time, but I represent this. The presentation is in Italian, and I'm not translated. And I translate it on time, in real time. Okay. What is WebAssembly? WebAssembly is a technology which can create a file with a special type of code to run on web browser. With the HTTP request, jQuery, Node.js, and JavaScript frameworks that client side, the execution of code is really slow, and in past this is a really problem. And in 2017, Mozilla Foundation participate a project to create a new type of code to optimize the scripting technology about browser. In the 2019, WebAssembly is official is a standard official of W3C, Worldwide Consortium. We have a chronostory from JavaScript to WebAssembly. In the 1995, the was born JavaScript with the XHTTP request come from ActiveX of Internet Explorer 5. In 1997, we have the standardization of JavaScript in ECMAScript. 1998, the Firefox integrates XHTTP requests. 2006, born a new type of compiler and virtual machine. In Illinois University, produce something LLVM, which need the base of WebAssembly. In 2005, Ajax will be a official and most important technology into the web, born from XHTTP requests. And in 2006, born the famous framework jQuery. We use it for years. We have in 2008 Chromium browser and the new technology of Chrome. Google produced the Google Chrome and the V8 engine for rendering the web, the modern web. 2009, from V8 engine, born Node.js, it's server-side JavaScript engine to create a simple server in little space. In 2011, we have Bootstrap for a visual engine. the framework to work the websites, to work with website and website design. In 2012, we have HTML5 to replace the Flash player, and born Enscripten and TypeScript. Enscripten is the base of WebAssembly. It is a compiler, and create and with Enscripten you can create a compile C++ and C code in WebAssembly. In 2013, was born the framework ASM.js, who can run the Enscripten WebAssembly, and with this, in the 2015, WebAssembly born like Mozilla Foundation project. 2016 born AngularJS from Google. In 2017 we have the group of Worldwide Web Consortium for WebAssembly. The work of Worldwide Web Consortium terminated in 2019 for standardization. This is the quite a bit timeline of technologies. Everything of this one of this piece of technology brought great evolution of web technology, but it was really heavy to elaborate, to work. And now we have the WebAssembly. This is a new type of code. This is a technology can compact complex script, complex code in for web browser, and now on either server side, web side, no, client side and server side, with complex functions with like code script written in C, C++, Rust, C#, Go, and this is a really efficient, nice. It's like it's run like a native code. WebAssembly we work in to be fast and portable, be readable and debuggable for security. Keep secure. WebAssembly is specified to be run in safe mode, sandboxed execution, like web code. It will enforce the browser's same origin and permission policies. Don't break the web. Is designed to don't retrocompatibility or destroy other technology. WebAssembly have three types of representation of in web. We have the simple source code in C language, and we have here a factorial function, a linear assembly bytecode. It is intermediate representation, and we have a sort of assembly. I come back. A sort of assembly. You can see this one, like a assembly code with native assembly code, and we have a binary coding or representation of byte in hexadecimal form of this assembly code. The size of WebAssembly is really short, is light in respect of JavaScript for the same function. We have the language. It could be represented by the S expression, is a middle language from source language and binary code. We define in here a module, import math, exp, function. There is an import with a params, result F64, result F64, and we are export double exp for export and reading from JavaScript. After I can see you the difference. Okay. By default, WebAssembly not provided with DOM interaction with DOM elements. We cannot directly interact with object like text box or options. There is a trick to do it, but natively is not do it. We can export a function with to JavaScript in the browser. We can create and export objects and structures for to interact with script with the browser. To use it in the WASM library in JavaScript, we need a code called glue code. We link the code in the WASM and get the JavaScript the possibility to execute the function in the WASM. In the WebAssembly are only 3 native types: double, int, and char. There is not strings, but we can we will see the trick to use it next time. WASM and JavaScript interact each other in a memory shared object called memory. The object is divided in pages of 64 kilobytes. It is possible to set the cache, the memory cache, increment the number of pages that increment the shared page standard. Inside of cache will be inserted pointers to strings. It could be treated like array like a C code. A script, it is the core of WebAssembly, is a low-level virtual machine, open source, to compile C and C++ in JavaScript ECMAScript code, and it is optimized to like native level code. The WASM file are the package of our package file of WebAssembly. everything is a meet a University of Illinois open source license. A script could be compile C++ code in JavaScript and in WebAssembly, optimize the code, and give a series of API who permit who can the interaction with browser. And script.h can grant the interaction from WebAssembly and browser, HTML5 for the interaction from with events of HTML5 with the native code, Rainbow.js with permitting the interaction from C and JavaScript code. File System API permit the interaction with file system. Fetch API needs for call for XHR request with the web API, HTTP GET, PUT, PAT, POST from IndexedDB data. Modules, we should be show the modules in the future. Val.h is used to transcribe JavaScript code in C++. Bind.h to include bind. User needs to bind the C++ in JavaScript. Trace it used for tracing memory and debug application. You can use WebVR, Web Virtual Reality. You can use asynchronous calls, but it is disabled because the exploit called Spectre could be attack the systems by web. Now, to link the C++ and JavaScript, you can use WebIDL. This is a standard language for interface, or Unbind. The version of the Unbind version don't support C++, but WebIDL, yes. Now, we can show something about code. There is online, because we are CPP developer, and we work with code. Now, this is a simple code, classic hello world plus C. I have this code in C because it's more simple to manage at this time. We have you can use C++ instead of it. This is a C++ code with SDL. We are to install to start with the script and WebAssembly and with C or C++ and not C# or Go or Rust. You need to install Nscripten. To do it, you need to clone the Git repository on your machine with this one and activate the installation. You need the WebAssembly. You need Python 3 to execute it. And now I explain you something. For example, install I'm using Linux for simple. There is several things already installed. You need to do it. Wait a moment. I installed in CppDay20 the mscripten with this one, git clone core, git clone the scripten core msdk.git, and you can install lastest and activate lastest. I found so difficult to work with versioning. Can be problematic, the versioning. The compiler you find in cd upstream ls cd mscripten cd mscripten ls. The compiler is AMCC and AM++. AMCC is generic compiler, is AM++ for C++. We need an example. Hello World C or Hello World HTML. If you compile Hello World C, GD GD. We use Node.js to show the things. This is the WASM, and this is the code generated from C++. Okay, we can we delete this one, and we work to compile mcc hello world .c, and we recreate without a name. We recreate the code transformed from JavaScript to C code to JavaScript to ECMAScript. We have several things to show: the module of environment. We have several things to do it, but we want the WebAssembly. WebAssembly out.wasm. But you cannot understand what is it, because it is really complicated to read from with a textual editor. And we work is s wasm equal 1 out hello world dot, and you should be we have a little bit exports for. Okay.
Sorry, Lorenzo. It's too small. They cannot read. Can you make it bigger?
One moment.
Thank you.
We can compile HTML file. This is the simple in the mscript.org, and you can compile it and transform it into WASM. Okay, we have hello world. So we can go to public and show. We have demo.js, hello.js, hello.wasm, and we have index, where we can include the WebAssembly into the structure. This is the clue code. We have was memory, WebAssembly.memory, because with memory we have unit iterate to string buffer, and we have the text decoder to decode the strings. Now, if run node node server .js, you can see this one. Now you cannot see too much. We need to enable the developer tools to see the WASM load. Now we have as event listener, we receive new string from C WASM value, instanziate la streaming fetch program.wasm, e quindi and then you import the WASM to use. You don't want to work. They don't want to work. Use it Chromium. Just a little bit more efficient. Ok, we have program.wasm and it is compiled, okay, with int const 42. It is like no, is this one? No. No, this one. Ce l'abbiamo. Ok, one moment. Index. Why change to hello, not wasm? And restart, refresh the page. And we have this one. It's little bit complicated. Why? Because we have a printf function. And it could be a little more complicated. Now, if you want to see more detailed things about it, you could use a link with WasmFiddle. WasmFiddle is online editor for Wasm and what. The what is in simple format, intermediate code representation. Ok, we have a simple. Vabbè. Facciamo così. Okay, we have the text format one we build, and this is the intermediate format of this function. This is WasmFiddle, and this is the glue code. The glue code to run the function, in this case with int main. We have I should find no, okay. If you don't want to install all the script, you can use this one, or you can use this one, WebAssembly Studio. It is a WASM inside the web browser. This is the Hello World C. And you could be show the code you can build, you can run, and it change the color of the web page in this case. The main C, you can find the function who printed hello world, with printf, and produced the WASM. In the debugger, Firefox don't give me some satisfaction to see the WASM. But you can download it to program.wasm, and the code is the same we show with program.wasm. So we did it more simple. Program.wasm is this. This is the translation in mid language, and not in WebAssembly, pure WebAssembly. This is a simple export main. Exported the function main, exported the memory, and the result is simple. WASM is ready, but you can print something. We do it. Printf. We build and run. But we need something else, because printf is included some We have this one. Okay, sorry, I lost this one. Haha. You can include includes build printf null. Okay, it's not so good, but I grant you it's work, but I need to do something. Okay. In theory, could be. No. It don't want to compile it correctly. Okay. I want to see you the what. What is the middle interpretation of no. Ranjuta is not a help us to wait. Please download what? Okay. Okay. With CppWrite, we should we did we see the intermediate language for the function. It's not the WASM representation. This is the binary. The WASM is the assembly. The weight, the W80 extension is for middle intermediate language. We need to show this one. It is the memory. Memory is the paging of the WASM. You need to set this one to and represent the 64 kilobyte memory. If you need more memory to use, you need to increment this page 3 or 4. Now, what program? What? Sorry. You can show the translation of WASP code with hexadecimal and import template. No. And this is the assembly. Once fiddle is good for to test, run, and compile WebAssembly. If you don't want to install or chain of compilation. You can see here the JavaScript, and I want to. Okay. Okay, this is the C++ compilation. This is ideal to SDL to C++ to WASM to use C, and it be compiled to do video, change video image like this one. This is the code of this one. You can change the color. No, sorry. Let me change. In the script, we need to in memory access reading. Sorry, public. No, not this one. One moment. What is I want to see you this one because the management of strings. You cannot have the strings in WASM directly. You need to treat in the shared memory, and it is a pointer to strings and not a simple variable. Okay, and you can include strings dot h stdo point dot h, and you can see everything. Now I show you this one. Sorry, the cats. Ok, andiamo. Localhost 222. Also, something.response for the favicon. This is the object of memory, the memory share. You need to show this really long to use. You have string.js. This is the generated code for glue code, and you pass something to use. You can see the code. You need to use the memory assembly, the initial page, okay, the read memory string buffer. You need this function to read the strings, and you can dispatch events to WASM. Okay, WASM ready. It's prompt to WASM. Where is the one moment? Mix. Okay, this is the program.wasm. It's really, oh no, I want to see you the demo, and not the demo.wasm. There is a problem with promise because the module global. Okay. Not it worked before. Because I need to sync.wasm. And give you the WASM and the model. You can console.log window not to ASM, and you can see the module you can load. Okay. Strings, not string. Okay, this is the module, but here this one not loading the module. Let's go. I don't know, but there is a problem with this, with exporting with modules. This is the thing. I'd like to see you something, but it's not working. Build. Usually we are using build something. Don't want script .h. Build. Okay. We see something. I cannot see you something. I like to do it, but I have something problem to compile it. Yes, okay. Log. One moment. Log. Ctrl C, Ctrl V, and that string. Okay, we minus triangle. Okay, extra also, nothing. Yeah, then work, nothing work like you want. And this one, you need these things. There's something problem with that. Where? This module, no. This is the module compiled from WebAssembly. It is direct than the WebAssembly. It is optimized, but it's not optimized at all. I'd like to see you. Something better, but export, perché noi we have export the function, export get string. Well, it should be work. This one. Ok. Console effectively not work. Cos'era? You need to see, this is the module, and we need to have the exports of function.
Lorenzo, I'm sorry.
Sì.
We are running terribly over time. I must ask you to wrap up.
Okay. I'm sorry, I'd like to see or something function, but I cannot do it at this time. Sorry. We have some questions.
Yes, there are a couple of questions. The first one is, given that JS string are UTF-16 encoded, is the current best practice to use a re-encoded STD string or to work with a naive representation?
Repeat.
Is it better to use with a re-encoded STD string or to use a naive representation of in WebAssembly?
You can use STD strings. You should be with M++. You should be a strings .h include, and you could use the strings, the standard strings.
Okay. There's another question, and how much of the STL is supported? Is it possible to launch STD threads?
STD thread, I think no. There is something, several things not implemented on C++ for security reason. Threads are not these are part of implementing, because it could be used with processor bugs to intercept keys or something. But on the site scriptem.org, you could find everything you need about it. C++. There is several things about it. Give me a moment. There is another question?
No, there's no more questions.
Okay. But Threads is blocked for security reason. I read it several times ago, but I think there is the problem. Fiber.h it could be the include you can use to do it. No, if there is not other question, I think you can.
And I see no further question. Thank you very much, Lorenzo, for your presentation. Thanks to all our participants for listening. I encourage you to follow up in the networking area and meet up with Lorenzo if you have more questions about his presentation. Thanks a lot.
Okay,
and
thank
enjoy
you.
your lunch.